No problem.
All right, we'll go ahead and get started. First off, Happy New Year, everybody. Thanks for coming. Great crowd tonight. Hopefully it's some New Year's resolutions to have lots of people show up at every meeting. So I want to as always, thank our sponsor, Direct Supply, for hosting us and taking care of the pizza and everything else they do for us, letting us space. Thank you, Direct Supply. If you are interested in sponsoring the user group at all in any capacity, either a monthly meeting like this or a community deeper.net, come talk to me afterwards or reply to the newsletter, send me a note, let me know. We're starting to get organized for deeper.net. Currently looking by April 6th is most likely going to be the day. It's not 100% yet, but I'd say that's pretty likely. So if you have any questions about that, please let me know. A couple other quick announcements before we kick it off. On January 25th, there will be a Windows 8 Dev Camp in Milwaukee. There was a link in the newsletter I just sent. If you don't have that, let me know and I'll forward it to you. Otherwise, scroll to your email. I'm going to try to send out another announcement about that soon. It's a free event. If you are just getting started with Windows 8 development, I definitely recommend going to see it. It's in Milwaukee. I think it's at WCC, the actual coffee shop. But anyway, check your email and it has all the details there. In February, we're having a meeting, GitHub for Windows developers. So if you've heard about Git, if you've not used it yet, or you know a little bit about it, want to know more, come out to that meeting and you'll learn a lot about some of the workflow that some of the other developers are using. And in March, I believe we're going to have a SharePoint 2013 development overview. And apparently, it's not as horrible to program in SharePoint as it used to be. So, yes, I'm lying. No, I'm not lying. So keep an eye out for that. That is all my announcements. So with that, I will turn it over to Richard, who will be talking about behavior-driven development with Specflow.
Check. All right, let's get started. Well, a little bit about myself. My name is Richard Yu. And let's start with my development experience. All right, so I've been doing .NET for about 8 years. My very first program was on a TI-81 graphing calculator. It was, I was in math class and I was a little bored, so I programmed blackjack in there. And that was my very first program. So after that, moved to Turtle Pascal because actually where I went to high school in Commonwealth, that was the only language they had there for software development, and that was in the late 90s. After that, I went to school and then did some .NET development for a consulting firm. That was my first job. It was 1 year, and it was the most intense year of my life. Just kind of got thrown into it. 60-hour work weeks, working nights and weekends. It was a really daunting experience, but I learned a lot from that. After that, I worked about 5 or 6 years at an insurance company in Brookfield. And then now I'm at a financial services company in downtown Milwaukee, Robert W. Baird. So if you want to contact me, I have a Twitter handle, it's Richard Yu. I really don't tweet too much, I just stalk celebrities out there. And if you want to contact me by email, if you have any questions about this, or you want to say that I sucked, or it was awesome, just feel free to send me an email. I'm more than happy to answer your questions. So without further ado, I'd like to set the tone of this presentation, because I've been to many of these presentations myself, and there were many things I liked about them and other things I didn't like about them. So since I'm doing this one, I want to do the things I like. So first off, be comfortable. If you need to get up and stretch your legs, get up and stretch your legs. If there's any food left, go get some food. Be comfortable, because my thinking is that if you're comfortable in your chair, you'll be more apt to kind of listen to the content versus thinking about how hungry you are for that last piece of the veggie in the back there. Next are questions. So I'm doing something a little controversial. I'd like everyone to save their questions to the end because there's a lot of flow involved in this particular presentation. Plus, on top of that, you know what? I'll be honest, I don't know the answer to everything, and I don't think anyone claims to know the answer to everything. And we have a great resource here. We're a developer community. So if I don't know the answer to the question, I think it would be more of a disservice to not call on the person that does know the answer and share that information. So we'll have a question and answer session towards the end. So without further ado, let's enjoy the show. So I named this presentation 50 Shades of Behavior-Driven Development. And if you aren't familiar with the books, there are 3 of them. A friend told me about them. It's 50 Shades of Gray, 50 Shades Free, and 50 Shades Darker, and 50 Shades Free. And the basic premise of those books is that it's mommy porn. And I figured this is technical porn, but I'll keep my clothes on for this. So first off, I kind of lied to you guys. We're actually in a group therapy session. And this is a group therapy session because we're all gathered in a room and we're going to talk about our problems. So before we get into the problems, I'd like to introduce the Japanese concept of Kaizen. And have any of you heard of this concept before? Great. A few of you. So what Kaizen means is literally translates to change for the better. And in order to change for the better, you need to identify problems in your processes. And once you identify those, you can figure out ways to fix them and make your processes better. And a company that's really famous for implementing Kaizen is Toyota. Toyota identifies problems in their assembly line. They identify them and then they try to fix them. All to make cars more efficiently, cheaper, and better. So let's dive into the first problem of software development. And that is the problem of estimation, the million-dollar question. So I'd like everyone to stop and think, what is the current project you are working on? And if you don't do shit at your company, then this question doesn't apply to you. All right, so the million-dollar question, how long is it going to take to complete? Ooh. I personally really don't like answering this question because there's a lot of times that there are so many unknowns. And why is this so hard to estimate? Two of the main reasons why it's so hard to estimate is that you're trying to gauge the size and complexity of a project. And size and complexity may sound like more subjective terms, but they're really objective. I mean, it's hard to get what's complex for one person, maybe not complex for another. And sizing as well. When we say sizing, what does that mean? When you size like a big project, it's small, medium, large. Well, what does small, medium, large mean? Is it 40 hours? Is it 80 hours? Who knows? We don't know. So software development is an art, and the way to think of it is that if I gave everyone like a program to write right now, and work on it for a week, what are the chances we're going to end up with the same thing at the end of 1 week? Pretty slim to none. So we're all little software development artists in our living, not like Subway sandwich artists. We're software development artists. All right. So the other thing that plays into the problem of estimation are unknown unknowns. And this, we just have to accept for the fact that we don't have any control over what we don't know. And I think many of you have encountered this before. You spend a whole day figuring out why this grid won't load, and you find out it's this one stupid property that's labeled wrong. And how could you have predicted that in your estimation? You really couldn't. So we just have to accept the fact that we can't predict the future very well when it comes to risky stuff like that we uncover later on. The last thing that makes it hard the last thing that we look at that adds to the estimation problem is done criteria. So done criteria is really important because how do you know when you're finished with the program if you don't know what the acceptance criteria for the program itself? If you don't know when you're done, how do you know how long it's going to take? And that's a huge problem. So let's take a step back and kind of see why we have to give time estimates. And ultimately, if you're a business, you're managing resources, and to objectify ourselves, software developers are resources. And if you have a project manager or business analyst on your teams, give them props because they block you from a lot of the politics that go on when you're trying to wrangle for software development resources. So if we can give accurate estimates to the business, then they can better allocate the resources to what will give them the best return on investment. And you can say screw the man and say I don't want to give them accurate estimates, but this is important if you're running your own business. You want to know how long one of your projects is going to take, So then you can allocate your time more into delivering features that could possibly bring you in money. So that's the first problem. The first problem is estimation. So the next problem is, as we dive into the software development process, is the development process itself. And ultimately, when we start with a bunch of requirements, we get to production. Come hell or high water. If it's late, if it's 1 year late, it gets there. But we think the process is okay, but it shouldn't have taken us a year to get there. So what can we what can we examine in the software development process to identify the problems there? So there are three main problems that we face in the software development process. It's starting, testing, and completing. So why is starting hard? So think about when you start a project, you get the requirements, you just came out of the meeting, and you go to your desk and you sit down, you open up Visual Studio or whatever IDE you use, and you stare. You just stare into the mouse like, where the hell do I start? You start thinking of the classes and entities you might need to use, just think of the methods, and it's just not the greatest way to start. The other problem is testing. Now, whether you do it in an automated fashion with ready unit tests or manually testing, testing itself is not the hard part, it's knowing what to test. So if you have a program that has an input at all, there is in theory an infinite amount of possibilities that you can plug into that program. But it's our job it's our job and a job of the business to find that little small slice of tests that we use to test the system to kind of cover our business requirements. And the last thing is completing. Again, this is kind of goes in with the done criteria. How do you know when you're done when you don't know what needs to be done? So those are the three main problems in the software development process itself. So the third big problem that we face is the problem of communication. And this is usually a big one that everyone kind of talks about. But one of the major problems with communication are different interpretations of requirements. So how many times have you gone back and forth with someone? How many times have you read a requirements document and thought it meant something, but it actually meant something else? It's probably happened quite a bit. So what could cause some different interpretations is the use of a non-standard language. When you're developing software and you're coming up with requirements for that software, you should use the same language in the entire process. And I'm going to use 4 stakeholders throughout this, 4 actors in this entire development process. There's the product owner, which is the person that requested the software, the analyst, which gets the requirements from the product owner, the developer, and the tester. Now, many of you might be in places where you play the analyst, tester, and software developer all in one place. So it's keeping the language standard between amongst yourself is okay. But if you have a lot of people on your team, then you should work hard to keep the language standard. So a symptom of this is thrashing, and I think you guys are all familiar with thrashing. And so when you go and you get some requirements, you develop some software with what you interpreted, what you thought the requirements were, and then you go back and forth, context switching, to try to come up with what the business user actually wants. So I think the best way to describe this is with food. So let's say we are part of a consulting company, and we were hired to work for Taco Bell, of all places, and we're going to develop a point of sale system for them. So in the first iteration, they come over and they ask you, you know what, I want the order time to show up on the screen because I want the order takers to know how long the order is taking. Okay, order time, great. So you go in, you open up the software, you capture the time when the order was placed. So the person pulls up to the speaker, all right, we're going to record that time. And then we're going to just get that time all set, pass it to the display, show them the display, we're all happy. Awesome. So now we're done with this. We've wrapped it all up, we've closed it, we checked it in, we pushed it out to testing. Great, now we can work on the next thing. So the next thing that you work on is, you guys ever see those sour cream guns at Taco Bell? You're going to work on software that detects how many sour cream gun tubes are left in your inventory so you know when to automatically order them. So you're working on that for a day, and the product owner comes back and says, no, that's not what I meant. When I said order time, what I meant was the time from the start of the order to the end of the order. Oh, you meant duration. You want to know how long it took from the start of the order to the end of the order. So, okay, great. So the time the person pulls up to the speaker, we capture that time to the time they get their food and they pay for it. All right, that's duration. put it up on the screen. So you had to context switch for this. You had that ramp up time of 20 to 30 minutes to get back into the program and kind of get into that flow state, into the zone, to start coding again and fix this, this bug that's apparent in the software. So great. Close it out, push it to test, go back to sour cream gun program. So the user comes back again. You know what? The start of the order is not when the person pulls up to the speaker. The start of the order is when the order is actually submitted to the system. So now you're going to go through all this work again, and for what? What do you think is going through the software developer's mind right now? So it's such a pain in the ass to thrash back and forth this software. It's a pain in the ass. So what is going on here? What's the problem? So let's see. The problem is that we're trying to communicate intent. The product owner wants to communicate the intent of the software. And the issue is that the ideas are crossing boundaries. So what do you mean by that? So when we talk about boundaries, why don't we follow the path of an idea through the software development process? So we first start with an idea that gets conjured up by the product owner, and that idea gets interpreted by the product owner. It's like, okay, I want something, now I have to think of it. So once that person thinks of it, that idea has to come out and gets transferred. So this could be through speech or writing it down through some sort of medium. The idea comes back out, and the other person reads it or listens to the conversation. And now they need to interpret that argument, what you said and what you wrote down, and hopefully come back to the same idea. So what I mean by with ideas crossing boundaries, it's any of the arrows there, and usually it's on the right side. It's when the ideas come out of the person and then they go into the next one. So this causes a lot of issues. I mean, we want to try to fix and address the risk that's involved with getting those ideas out. So one of the most volatile ways of communication is speaking, because you thought you heard something and you didn't write it down. You go back and forth. And where this is really apparent, a good example of this, is actually at a fast food restaurant.
Welcome to the dentist. Can I take your order? Give me a double bacon cheeseburger. Double bacon cheeseburger is for a cop.
What the hell's that all? You gonna spin it now?
No, I was just telling him that so he makes it good. Don't spit in that cop's burger.
Yeah, thanks. Give me a pie, apple.
Do you want me to hold the spit? Just kidding, officer. Barba. So, do you want to dip beside your milk for a quarter more?
Want me to punch inside your face for free? I don't give any lip.
It's just a quarter, and look how much more you get.
I said no.
It's just 25 cents.
Hey, listen, guy.
He doesn't want it.
I can handle this Ramathorn. I don't want it.
Right. Beverage?
Give me a liter of cola.
A what?
A liter of cola.
Liter of cola? Do we make liter of cola?
Just order a large barba. I don't want a large barba. I want a damn liter of cola.
I don't know what that is.
Liter is French. For give me some fucking cola before I break loose.
All right, relax.
That look like spit to you?
Yeah.
So verbal thrashing is a pain. Go get speaking. All right, so we have all the problems laid out. So how do we address these? So one of the first things we have to do is that we need to break a project down. What I mean by that is that a lot of times you get a requirements document that's a big packet. And to do the estimation of that and to figure out what the dependencies are, that's tough. You have this big packet of paper. So what we want to do is that we want to break the project down into a set of user stories or features that we want the software to have. So the question is, how big do these need to be? Well, that's a good question. It's not going to be the same for everyone. Where at Baird, what we usually try to do is that we try to break down a feature that will take about 1 to 2 weeks of time. That is usually broken down to the point where we get actually an advantage. And the advantage is that, number one, it is easier to estimate smaller chunks of work than it is to estimate a gigantic chunk of work. Number two, you can actually start detecting dependencies within your features if they're broken down that way. And three, what this also offers is that you can prioritize your features a little better. So let's say you're in a time crunch and the person has to cut off a few features. You know what? This is the best kind of way to do it. Maybe we have pretty much a list of things that they want, and we can kind of cut some of them out. And what we do at Merit actually is that we actually physically visualize this. We put all the user stories on index cards, and we actually put them on a board. And the type of board is called a Kanban board. And we move the user story through requirements gathering, to development, through testing, and then through production. So when we break that down, we're more agile. We can actually detect more problems in the process when things are broken down into smaller components. So, what is a user story? Well, a user story first starts out with a statement. The statement is, as a role, I want something so they get a particular benefit. And this may sound really easy, but actually this is a really hard thing to do because you're forcing whoever the stakeholders, the product owner, to kind of think of what they want and why they want it. There are a lot of times when product owners request something that would be really cool, but it's not really necessary because it's not going to add as much bang for your buck, in their opinion. So once you have this feature, you need to do something to validate this feature, and that's acceptance criteria. And acceptance criteria is all the criteria that needs to be met, so that user story will be satisfied. We can say it's done. So how do we get to this acceptance criteria? Well, first off, the most important thing is that you need to work collaboratively. So usually when we have these meetings, we have all four stakeholders, and we try to have as many stakeholders as we can. We try to have a product owner that represents the business, an analyst there, a developer, and a tester. So what this offers is that it offers really fast feedback. So when you're actually grooming these user stories, you can get input from the product owner, whether or not they can tell you whether or not the requirements are wrong. The analyst can ask the right questions to see what the product owner really wants. The developer can offer technical insight, and actually a really important part of that is the tester, because the tester has to be able to verify what you created. So we need to work collaboratively to capture behavior. We need to capture what the system needs to do. And let's do it in a standard language. And where I see this most is that, actually I've seen a few examples where the reports are a good example. You have a product owner that requests a report. Let's say it's like the financial report. Analyst calls it a financial report. But then in the system, it's called like RPT 1235 financial. You know what? You should probably try to name it the same so we can be consistent throughout the entire process. That way the tester can see financial report and know exactly what they're testing. Now granted, you could go back and say, you know what, report 12345 actually is a financial report. But you know what, that's an extra step there. And we want to eliminate as many of these little steps that we need to get to the information in our process. So, I think the best way to kind of illustrate this is that we'll go through an example. And again, we're in this consulting company, and this consulting company is actually asked to make the entire operating system for a phone. And we're in charge of making just the phone app, just the part that makes the calls. So we go in a meeting and then we kind of get a user story out of it. So let's take a look at it. As a business user, I want a phone call app so that my users can make calls. So this is almost like a mission statement of the feature. This tells us what the feature is going to do. Let's groom the acceptance criteria. And I know grooming is kind of a funny word, but that's all I've heard it called. All right, so you go to this meeting and you get the acceptance criteria. You know, you guys are all the testers there, the software developers there, analysts. We're all talking and come with this. So I'm going to actually go through the pain of reading this because I think we've all experienced it before. The user will be able to press any key on the number pad. The app should only be able to dial if there is the appropriate amount of digits entered. The call button should only be enabled if it matches the amount of valid digits. When 7 or 10 digits or 11 digits with a leading 1 are in the display, then the call button will be enabled. If the number 1 digit is the only digit entered, then the call button will be enabled because this will forward them to the message service. When the user presses call, then dial the number. Alright, this sucks because what you're doing here is what I call lawyering. You actually have to read this and really interpret and try to think of what the person actually wants. That's not a good way to lay out acceptance criteria because even though this is more of like an easier case where we can kind of detect what the user wants and what the requirements need to be, it's still hard. We have to read through this paragraph and actually go through and underline and kind of annotate this to see what the product owner really wants. So let's take a step back. There's got to be a better way to do this, and there is. And what we want to try to do is we want to standardize this. So there's a format out there called given when then, and I'll go through these terms really quick and we'll go back through them just to kind of go more in detail. So the scenario is the description of the behavior, given a set of preconditions. When an action occurs, then you'll get a verifiable result. All right, let's go back. So scenario, this is the description of the behavior that we want to exhibit. And we're not trying to win the shortest sentence contest here. We want to write a sentence that actually really describes what this scenario or this acceptance criteria is going to do. Given some preconditions. So what does this mean? This means this is everything that needs to be in place before a certain action occurs. So let's say it's a login form. The username has to be filled in, the password has to be filled in before an action. So the action is, I think some people call it a transition state. So it's when you jump from when the preconditions are to when there's a verifiable result. So you have the action that occurs, like click of a button or enter another digit, and then there's going to be something you can verify. And this is the most important part, because how the hell do you know if your software is going to work if you can't verify what it's doing? So that's the format of the acceptance criteria that we kind of want to standardize, and it makes it a little bit easier to read. So why don't we go through the example of breaking apart this paragraph, and we'll group it into this given when then format. So first off, the original requirement that we had, and this is just like one of those sentences in there. If the number one digit is the only digit entered, then the call button will be enabled because this will forward them to the message service. All right, so this is a sentence. This one's an easy example. It's easy to read. So let's kind of group this. So what are we going to name the scenario? It's a shortcut to the message service. That's what it's going to do. What has to be in place before we can hit have the call button enabled? So we first have to have a phone app. That's a simple class that could, or an object there. But trying to think of stuff within classes and objects, you just want to think of what the business user thinks it is. So given a phone app, and there are no digits in the display, so it's all blank. When the one digit is entered, this is the transition. This is what happens before we get into a verifiable result. And the call button should be enabled. All right, so this kind of lays out what the behavior of this particular action is. So this one's a pretty straightforward one, so let's group another one. All right, so this is the nasty one. The call button should only be enabled if it matches the amount of valid digits. 7 or 10 digits or 11 digits with the leading one are in the display, then the call button will be enabled. Pretty ugly. So let's just group one of the parts of that. I think I see a few in here. So one of the scenarios is a call button is enabled with 7 digits entered. That's a 7-digit example. What are all the preconditions that have to happen? So given a phone application, and there are 6 digits in the number display, so that's already in there. When the user enters in another digit, what should happen? The call button should be enabled. Now I know phone numbers shouldn't start with 0, but this actually outlines a scenario in a more understandable form that we can detect these problems a little better. So you can see now that it's in the given when then format here, you bring it back to the product owner and say, hey, you know what? Should the first number be 0? Because it probably shouldn't be. Great, we can identify problems in the requirements gathering process a little bit easier when stuff is laid out like this. Let's do one more. So next scenario. Call button enabled with 11 digits and a leading 1. So what are all the preconditions here? Given a phone app, and there are 10 digits in the number display. When the first digit is 1, so this is all that's there. When the user enters another digit, and the call button should be enabled. This is getting a little monotonous, but laying stuff out like this makes it easier to define what the system should do. So let's take a look at the original acceptance criteria. This is what we had before. We had this big, ugly, nasty paragraph here. And we can group this into a list of scenarios. Now granted, all of them might not be there, but usually take a first stab at it and see how it works out. During the whole development process, you might detect even more, and then you bring that back to the product owner to see if these are valid cases. So this is great. We're all on the same page, and we have this We feel great. You know how great we feel? We feel this great. We feel like Rick Astley. We're all on the same page. So there's something that's going through each one of our minds. The product owner, the analyst, and the developer, and the tester. And Rick Astley says it best in the second line of the first verse. It's what I think you're doing. Yes, you know the rules, and so do I. That's what should be going through everyone's head on your team. Those 4 people should know what the rules are. So great. We have the acceptance criteria. It's all grouped into these user stories. Now, the software developer pulls in this one user story to work on. So how do we usually start this? We sit there and we think of all the classes and entities that we're going to need. All right. We think of attributes that we might need for those classes. We're going to maybe think of the methods that we're going to need to use, and then we're going to either write some unit tests to kind of prove this, to prove that our software works, or we manually test, just kind of a pain in the ass. So this approach is not the greatest approach because it actually produces a lot of waste, a lot of code that you might not need. And the less code you have, the easier it is to maintain because it's physically less amount of lines you have to look through. So the way to illustrate this, the best way to illustrate this is, let's take a scenario here. You are asked to be a chef, and you're going to open this great new Italian restaurant that's going to open down the road. It's called the Gala Garden. And as the owner, I'm going to ask you, as a chef, you want to go out and get a bunch of ingredients so you can make food. So you can make entrees for the clients that are going to come into your restaurant. All right, so I'm the chef here. What am I thinking of? You're going to need some vegetables, right? Tomatoes, onions, scallions, maybe. What else? I'm going to need pasta because I want to make a pasta dish. What kind of, bow tie pasta or maybe linguine. And you need some meat, so calamari, maybe like some fried calamari or some seafood dish, or I probably want to make a soup or a salad or something, so I'm probably going to need some stock, and then from there you'll get to the menu. So the problem with this approach is that we're buying a bunch of ingredients for stuff we might not make. So let's take this chef example, and let's turn it on its head. Let's start with the menu, because that seems the most logical place to start. So great, so let's see, what do we want for an appetizer? You want fried ravioli, you want calamari, you can tell I want fried stuff right now, because I just had one slice of pizza. We want some soup. All right, great. I'm going to make a minestrone, Italian wedding. Entrees, I'm going to have fettuccine alfredo. I'm going to have clams linguine, and for dessert, I'm going to have tiramisu. So we have our menu here now, and that's like the scenario behavior descriptions that we came with before. Now let's go on buying the ingredients. With this approach, you're going to end up with a lot less waste, and in our case, we're going to end up with a lot less code. So here comes the concept of test-driven development. Have any of you heard of test-driven development at all? Okay, so test-driven development is like the chef example turned on its head. So instead of starting with the code, let's start with the menu. Let's start with the behavior and the scenarios. So the technique to do this is that you first write a failing test. And when I say failing, it doesn't even compile. It doesn't even work. So you write a failing test. You write enough code to pass that test. So now that scenario is proven in your system. Then you go back and clean it up. And you clean it up at your heart's content because you have the test to cover the behavior that you put into the code before. So you factor something wrong, the test break, it's like, you know what, I got to undo that because that broke the rules of the system. All right, so that's kind of the technique, but you could go in and write unit tests. But, those are not the easiest things to read, to put into plain English. So wouldn't it be great if we could take those scenarios that we came up with before in the coding session, pull them to our development environment? Well, there is, and that tool is called Specflow. So Specflow is a product that that integrates into Visual Studio, uses the Gherkin language, which actually happens, or Cucumber, that actually happens to be formatted in the given one then format. It runs with test frameworks, and we'll be dancing on the ceiling and everything works, so Lionel Richie approved. So that's the Specflow part. Now I'm going to go into a little code demo here later just to kind of illustrate this. So how does this work? So we first, on the left, we have the feature file, and the feature file contains all of our rules in plain English in one file. If we jump over to the right side, it's our code base. It's the actual physical code that we're going to compile into the library. And the fixture file binds the plain English language on the left side to the code on the right side. So there's actually kind of a productivity tool, and I apologize because when I first made this presentation, this tool was free, but now you actually have to pay for it. It's a guy, I think, in New Zealand that excuse me. It's a guy in New Zealand that actually made this. It's one guy. He actually made a pretty cool tool for Visual Studio. It integrates in there. Excuse me. So what does nCrunch do? nCrunch actually continuously builds and runs your tests within Visual Studio. So you kind of have that instant feedback of when you write your code, you can see whether or not your tests have passed or failed, what lines of code are actually covered by any test, if they're covered by a failing test or a passing test, and it actually tells you whether or not your project is compiling. So you'll never actually have to hit Control-Shift-B, for a while. So I think the best way to demonstrate this is to take our phone app and let's code it up. All right. Here we go. Fire Visual Studio. All right. All right. Start a project. All right, so we're going to go and create the phone application for the project. All right, go in. I'm going to create this test class, this test library, or this code base. Go and clean it up. Then you freeze. So you guys ever see a backed up toilet? This is like a backed up toilet. And let me explain how. It'll be clean. So with a backed up toilet, you do three things. Number one, you stop and you stare and you kind of take in the situation and see what the hell is going on. Two, you think of all the tools and actions you're going to have to do to actually fix the clogged toilet. And three, you're going to actually go implement and find that plunger and unclog that toilet. This is the same thing. One, we're actually staring at this because we don't know where to start. Two, we're kind of thinking of all the classes and methods that we're going to have to use to prove the behavior. And three, we're going to try to actually code it up and see if it works. So that's not a good way to start. Again, we're kind of doing this blank stare and try to think of a good place to start. So again, let's start with the test. So we're going to create a test project here. Great. So with test projects, you want to keep those separate. You want to isolate that from your code base so it doesn't have any chance of mucking that up in case your test suite doesn't compile. So we're going to create a test project here. And usually the convention I use is that I usually name it the project that I'm testing with .test after. All right, we clean it up. So the next step here is that we should add our Specflow plugin. And you guys ever used NuGet before? Most use NuGet. If you don't use NuGet, you can actually download this as an installer as well and install that on your local machine. But in this case, we'll use NuGet. All right. And it's right out there. So I'm going to find Specflow. Get that all in there. All right, so one thing with Specflow is that the default test runner is NUnit, and you want to use MS Test because that's integrated in. MS Test is a little bit easier to use as a test runner. So here you actually have to add an attribute in the config file. And actually it took, I actually went with Carl back there, and it took us probably like half a day to figure this out. So I saved you half a day's worth of work. All right, so we update that config file. That's right. All right, so let's add the feature file. So again, the feature file is the file that has the plain English in there of all the behavior that our system needs to exhibit. So you go in here and you add a Specflow feature file. And usually the convention that we use is that we name it to the same as the user story. So create that. So this is the default thing that comes up. It's the kind of silly calculator app. But what this offers us is that if you look here, this is actually living documentation. When we put all of our scenarios in here and the name of the feature, this is actually live in the system. Granted that it's pushed to production. So then I think we all hate to update documentation after you've updated the code. It's a big pain in the ass and no one wants to do it. So why do the work twice? You can do all the work here of capturing the requirements of your system. All right, so we're gonna get rid of this crap here. And then we're gonna put in our feature that we came up with. So the phone app. So we have the straight up sentence with user story right in there. Let's add the first scenario. So the first scenario was, the first scenario we're going to work on is the 7-digit scenario. So here, we'll put this in there. So right now we're going to try to run the test. Well, we're going to end up with an error here because this is all the project has. It has this little feature file. And actually what Specflow does behind the scenes is that as soon as you edit the file, it actually generates another file behind the scenes that MS Test can read and use through its test run. So what's happening now is saying that, what does it say? Assert inclusive fail. No matching step definition found for one or more steps. And what that means is that it's trying to run that given statement, but it can't find any code that's bound to it. So the next step here is actually to add the step file, and this is the fixture file that binds the feature file to our code base. All right, so this one. All right, so let's add the step file. And it's right in there in the little adding item selector. And usually the convention we use here is that we do the feature name filing and then we do steps after it to signal the step file. So here I actually struggle with deleting this code here. It was actually 11 at night when I was doing this. But they give you kind of an example here that actually run against their sample scenario there. So the thing to know with the step file is that all it is that it's a bunch of procedures in there, and you add an attribute to the top of the procedure. And what that attribute is maps the givens, whens, and thens. So it's a given and a regular expression in there. And as soon as the test runner runs, it takes that given, like a phone app, and it actually tries to look for that in your entire project. And that's one of the kind of drawbacks of Specflow is that anything named with given a phone app, it'll run that. So we try to keep our scenarios, worded a little differently so they won't run them. They don't kind of collide with each other. But the attribute up there is just the given attribute. And so what the test run does is that it goes through each line in sequential order and tries to find the procedure and executes that procedure. So we have our given statement. So next, now that we have our step file here, our step definition, let's add some code. We're going to try to run the test to see if it passes. We're going to get the same message, but now there's going to be one less in there because one of the givens are actually covered. And I don't know if you can see this, but actually when the Specflow test is covered by a step, it turns black instead of the little light purple. So now let's add some code. So a phone app, what does that look like? All right, so it's probably going to be some sort of class called phone app. We code it up. Now great, you know what? We can start adding code to our code base now because we need to get this project to compile. So we're going to add that, add the class. Make it public. And we will add a reference to this to kind of finish it off. I'll tell you what, the first time doing this, it's really hard to not dive into it and start coding everything within this phone app class because it's the temptation is there, but it actually is kind of a discipline. You have to hold yourself back from just cranking out as much as you can. You can see this compiles, but test will fail. So as you see here, it was a pain in the ass to actually write a little bit of code and then run the test run and see the test pass. And that's where nCrunch comes in. nCrunch does a continuous build and test. So we're going to go and set this up. And I don't know how much it is. I think it's around $100 or $200 for the personal license. 160. And I think the corporate license is $300 or something. Yeah, it might sound like a lot, but this has saved our organization a ton of time because it just offers that instant feedback of of the health of your project. So I'm just going to run through the setup here pretty quick. So when you start Uncrunch, here are some of the features. So you can either run your tests one at a time or run them in parallel. It tries to say when you run them in parallel, it's going to run them in kind of segregated processes so weird stuff doesn't happen, but I don't think it really matters here. I just do one at a time. So next. So the engine execution mode is next. So the first feature is use the default feature, and it's run my tests active automatically when changes are detected. So as soon as you hit like a space bar or type in a letter, it's going to kick off again. It's going to compile your project and try to run all the tests. The other option is to run them manually, which I feel defeats the purpose of Uncrunch. Only automatically run impacted tests. So it tries to be intelligent and try to run only the tests that it thinks are impacted by your code. Or you can only automatically run tests. You only run tests that I have pinned to the task window. So Uncrunch comes with a little task window up there that you can actually specify which tests you want to run. So, our computers are fast enough, we can run all the tests, so we usually select the first feature. First thing there. So the next feature, the last thing you have to set is ignore all my tests by default, which is default, which I think defeats the purpose of an Uncrunch. Or let all the tests run, which is probably what we want to do because we want to see all the tests in our system. So that is set up. We'll start crunching. So there's a little test window that comes up. You close that, get rid of it. So if you notice on the screen, in the bottom right-hand corner is the circle of awesomeness. That circle tells you the current health of the code you're working on. If it's a red circle and there's a number in there, the red circle means the code compiles, but there are that many failing tests in there. If the circle is beige with a 1 in there, it means your project isn't compiling. And if there's a green circle with an green N in the middle, that means all your tests pass and your project compiles, which is a happy state. So instead of going back and running all the tests again, let's start coding. Let's add the rest of the features in here, the steps in the step file here. So next, we want to cover the end there. So the thing with the ands in there, the ands can only appear under givens and thens. And to attach those to the step file, if it's under a given, you just do another given with an attribute, and that will bind to that given attribute. So we look here, we'll do the number of digits is 6, and then we'll just run through some sort of loop that adds as many digits as we requested, so 6 in this case. And we'll add that to a local memory variable, current digits, that holds all the digits that are currently in the display. All right, so that end is covered. Let's write the when. So when, this is the transition state. This is the one thing that needs to happen before we have some sort of result we can verify. And that is when we enter another digit. So all we need to do here is add one more digit. In this case, it doesn't really matter, so we should add like number 4. And there, after number 4 is added, we need to verify. This is the point of verification. We need to run something to get a result from procedure to see if the call button should be enabled. So we write that code there. And it sucks kind of for IntelliSense because the procedure doesn't exist yet, but we write this code out now and it doesn't compile, and we write enough code to make the solution compile. So here, for simplicity's sake, I'm going to add then. So that we're able to, whether or not the call button is enabled, we want to store that locally. And the last thing we want to do for the then is then we want to assert to see if the call button is truly enabled. So now, the next step is to actually implement that call button should be enabled. We're going to generate method stuff. All right, Uncrunch is pretty fast. Granted, there isn't much code, but it is pretty quick. So what it offers too is that it gives you any exceptions that happen in your test setup, and you can hover over them and see what the exception is. And you see the exception here is exception gets thrown when you generate the method stuff. It's a not implemented exception. So now that this is in place, let's actually write some code that actually proves this, that will actually implement this behavior. Definition. All right, so it should be 7 digits. We are green. We have one scenario that is passing right now. Our code compiles, our test pass. We've proven one scenario here. That's pretty sweet. I mean, and look at how much code we had to write. Not too much. And granted, actually, we probably didn't have to write that else statement. All right, so we have one of the scenarios down, and that was pretty plain Jane example. So let's kind of explore some features that Specflow offers us. So let's do this by, let's illustrate that by putting in another one of the scenarios. So the scenario is call button enabled with 11 digits with a leading 1. So if you look up there in the scenario, 3 of those things are already covered. The given phone number is already covered by that step, the when and the then. All we need to do is implement those 2 ands there. So let's do the first one. The first digit is 1. All right, so we'll do a given there, have an attribute of given, and the first number is 1. And we'll say the current digit is 1. Next, there are 6 digits in the, or there are 10 digits in the number display. And you know what? This looks a lot like that given down there. It'd be really great if we can reuse it. And we can. Remember, the top of the Specflow attribute is actually a regular expression. So what we can do there, actually, I'm sorry, another thing that Specflow offers is kind of a test setup and a test breakdown. So if you want to do anything before the test run for this particular class, you tag it with before scenario. So it'll create an instance of this class, run any before scenarios, run through all of the given, whens, and thens, and then run the after scenario feature, which will do any cleanup that you might need to do. So let's replace this given statement with something with a regular expression so we can reuse it across these tests. So what you see there is that parentheses dot star. So it's anything in there, it can go in there. And what's awesome is that it'll get passed in as a parameter to the step procedure. So in this case, you can cast it anything you want, and if it doesn't cast it already, it's going to throw an error in your test. But here we'll just do the number of digits. So we've actually kind of reused one of the steps between a couple scenarios here. So we're doing a little bit of code reuse. Right. So now they have that. Let's actually write the code to prove this, behavior. So we go in here. All right, we wrote enough code to pass this, but there seems to be a problem here. We never checked whether or not there was a leading 1 in the phone number that we currently had. And this actually illustrates an important point. All of the scenarios we wrote down, and I don't know if it's kind of human nature, we always test the happy paths. But we also have to test the unhappy paths as well. What happens if we don't put in a 1 as a leading digit? So why don't we actually write a counterexample to this and set a non-1 number as the leading digit? So we're going to do another scenario that actually isn't in our requirements. And we are going to say, we're going to set the first thing to So if we take a look at the scenario, the call button is there with 11 digits and a leading 0. So if we look at the color coding here, the two things that are purple is that the first number is 0, and then the then statement. We don't have one that covers the disable. So you know what? That first number is equal to 0 looks awfully like that first number is 1. So why don't we use a regular expression to pass it as an argument? Alright, so it's highlighted. All right, so we replace that number with a regular expression there, and we pass it as a number. So now it's covering 2 tests now. And then we'll add the assert behavior. So the button should be disabled. And actually I need this scenario on there. The call button should be disabled with 11 groups and leading 0. So it gives us the exception that gets thrown right there. This test does not pass because it's not returning a true. It should be returning a false, but it's returning a true. So let's go in and actually prove that. And actually implement that behavior in the code. highlight that. Boom shakalaka. We have a green N on the bottom. We have code that compiles and improves these three scenarios. And actually this happens a lot when we develop software, is that in this particular process, we come up with more scenarios that the business didn't even think of, because usually they think of how the system should work, not how the system should work if there are unhappy paths that we go down. So there are a couple other features that Specflow can offer, and one of them is scenario outlines. So if you look at those two scenarios, they look pretty similar. So it'd be cool if they offered something that they do offer something where you can actually run kind of a table-based input approach here, and those are called scenario outlines. So scenario outline works the same, works kind of like a scenario. The only difference is that there's outline in there, and you can name that scenario. So I'm just call this test permutations or phone numbers. And we're actually going to take one of these tests as a template for this. We'll take this as a template. All right, so we have our template here. So now we need to kind of give it the table input that we want to feed into the scenario. And you see the error here is that there are no examples defined in the scenario outline. So the keyword here is that you use examples, and you'll give it a table here. So examples, you give it a table and you give it a bunch of columns. And what it will do is that it'll take each one of these rows and plug it. Take each one of these rows, replace that particular part in the code with that value, and then run one test. All right, so we plug the first number there, we'll plug in the other two as well. All right, it's green, but it's not running any test. So let's add some scenarios here, some examples. All right, so we have our first one, which is the 010, or the 010 disabled. And we'll add the next one. All right, so that's running. And now we have a failing test, because it's a leading one and there are 10 digits in there, it should be enabled. And see here the tester. Now, one of the crummy things running through these scenario outlines is that it names a test with an underscored number. So it's kind of hard to decipher which test it's running, or sometimes it picks like the first column in there in the examples and appends that to the base scenario outline text. You see here it's underscore 1 right there. So now we'll change it to enable. And parentheses are running. We're going to go green. We're going to go green. We agreed. All right, and we'll just, for argument's sake, we'll just add the last one as well. So great. So that's an example of a scenario outline. If you have like a table-based approach to plugging a bunch of data for each given scenario into a particular view. So the last thing, the two last things I want to demonstrate are you don't only have to have a regular expression to put as input to a procedure. You can also have tables. So here, we're going to test the 1900 number. So here, we have an AND in here with a table here. And what we need to do is that we just need to write a given for this. And the argument actually is just a Specflow type table that looks just like a .NET data table. So we'll go over there and implement that. All right, so given the numbers entered so far are, and the argument is a table, and it knows to take that table below that and input it. So we're just going to iterate through all the tables in the rows and append that to the current digits. So the last thing you can do here is with regular unit tests, you can ignore them. You can tag these scenarios right in the feature file instead of going into the code that gets generated by Specflow. In fact, you probably want to do it this way. So if we want to ignore the 1900 number test, so we don't call those anymore. You know those commercials like overnight. So that test is running right now. We're going to add ignore at the top. And all the attributes on top of the scenario are prefixed with an @ symbol. So you symbol ignore, that'll ignore the test. But another thing you can do is actually you can run the test here and you'll see that it's skipped. Another thing you can do is that, let's say you have a bunch of slow running tests, and you want to just run those like overnight. Like, it doesn't really matter if they run while you're compiling. They're like integration tests that you test interactions with the database. What you can do is that you can tag these with as many of these @symbol attributes as on top of the scenarios as you want. And the way you do that is just do the @symbol on top of it. So the automated part of automated tester development is that you take your build server, like TFS for example, and you make a build definition. So in that build definition, every time you check in code, it'll compile your project and it'll run all the tests and it'll report back the health of your current project. And this is what's known as continuous integration. Does anyone here use CIs at all? So you can constantly get the status of the health of your system. And actually, where we are, we have this really ugly dog that we pass around. So if you break the build, we do a huge ceremony where we march down to your desk and we give you this ugly ass dog that you have to display proudly on your desk to know that you break the build. And it's up to us and it's up to the person to try to fix the build as fast as they can because we don't want any broken code in our system. All right, so the big question here is, all right, this is good for new stuff. What about stuff that's already existing out there, legacy code? Well, here we kind of have to weigh the pros and cons of actually writing tests against legacy code. And that comes with risk. So if you're making a change to legacy code, let's go through the process of doing that. You'll first have to isolate the logic that you're trying to change. You need to put that somewhere. You need to write a test against that to prove that it's currently working the way you think it is right now. And then you have to write another test to implement the new behavior. And this takes a long time, it really does. So you really need to weigh the risk of changing this code with how much time it's going to take. Now, if this is something that affects like financial statements that go out to people, you better damn well write some tests against that because people get pretty angry when the right numbers aren't on their financial statements. So there really is no true answer for updating legacy code. It's a matter of risk and how much time it's going to take. So let's bring this all around and let's take a look at the original problems that we had at the beginning of the presentation. So we had the problem of estimation. First, we have the unknown unknowns, the thing we have no control over, and we have to accept the fact that we can't control those. Size and complexity. So now that the project was broken down into a collection of user stories, and those user stories have a collection of acceptance criteria in there, and all the scenario behaviors that particular user stories need to exhibit, it's a little bit easier to size these stories now. I could probably tell you with a little more accuracy how long each one of these scenarios is going to take. And what about done criteria? You know what we have here? We have a checklist. So now that we've implemented all these scenarios in our user story, we're done. Unless the user comes back and says, I forgot about this, that may get tacked onto here, and we pull that back in, and we add a couple more scenarios. Let's take a look at the development process. So starting. Starting is a little bit easier now because we start with the tests. We go we do a top-down approach. Testing, we know what to test because we're writing the test first. So all the behavior that we're exhibiting in the system is already under a test. And completion, it's a check mark, it's a list. Once you get the scenarios done, we can check them off as complete. So what about the problem of communication? It's communicating intent and ideas crossing boundaries. Well, really, the key here is collaboration. We all need to work together to figure out what the requirements are and shorten that feedback loop. Because we know how difficult it is that when you send an email to someone, it takes them a day to answer and you're waiting for that. That feedback loop is way too long, and a lot of people, might forget about certain things that they might not have thought of in their, short 10, 15-minute grooming sessions. And actually, the technique that we use is that someone takes a stab at all the scenarios in a given user story, and then we get together and try to figure out if these scenarios are correct, if we need to add any more, or if we have to modify them. Different interpretations of requirements. This is where that short 10, 15-minute meeting to discuss the scenarios helps a lot. We can actually figure out what people don't understand right away. Non-standard language, let's try to keep true to that. Let's try to keep the same language throughout the entire process. Let's use the same terminology from product owner to testing. And thrashing, you're never going to fully eliminate thrashing, but this should, since we're outlining what the system needs to do a little better, thrashing should be kind of toned down a little more. So let's take another step back and figure out why the hell this is so hard. And this is hard because when we think of what a system needs to do, it's a process. So when we describe a process to someone, it's really difficult for us to do because our mind only makes shortcuts. So if you ever give directions to someone to your house, You could drive there with your not with your eyes closed, but you could drive there no problem, not even think about it. But when you give someone directions to your house, wait, hang on, who gives directions? Anyway, when you give the directions to your house, you know, it's really hard because you actually have to think of the actual turn you have to make and what, you know, the McDonald's landmarks at another corner. Take this for example. Let's say, you know, you had to fill up your car with gas. All right? Write down to your procedure. Tell someone how to fill their car with gas who has never seen a car or has never seen a gas pump before. It's pretty hard because for us, it's all short-circuited. Our brain makes shortcuts. So, is behavior-driven development the answer? No. There is no silver bullet out there that's going to solve all the problems. But this should help with some of the problems with identifying the requirements and writing the acceptance criteria for the user stories so we can get our product, so we can get the requirements for our product a little bit easier and make the development process easier as well. So that, let's talk about it. Do we have any questions? Anything you want to add?
So have you guys ever looked at using fitness?
Yes, so the question is, have we ever thought of using fitness? And yes, we actually, in our organization, we actually had two groups. We had one that liked Specflow and one that liked fitness. And what fitness is that it's a wiki-based approach, a web-based approach to run all your tests in like a kind of a table-based format. And the problem we have with that is that there was a lot of ramp-up time. We had to set up a web server on our machine. It was hard to get it integrated into our build server. And ultimately, when you look at Specflow for developers is actually a lot like a design tool. It helps us design our code behind the scenes. So I don't know if you guys ever heard of the concept of emergent design. So when you're building from this top-down approach, your design will emerge from all of your tests instead of going up front and trying to design all the classes and entities at once. All right, so what did you say? Oh, spitting out the results. Okay, spitting out the results of the features of the Specflow. Actually, there's a tool out there, and it's a play on all of them. Pickle type, cucumber, it's a gherkin language. There's a tool out there called Pickles. So every time you check in your code, it'll build, it'll run all the tests, and the Pickles utility will actually take all your scenarios and write whether or not they passed or failed to a web page. So actually, there are a few projects in our place right now that actually have a Pickles implementation. So actually, the product owners go out there, and they go, and the QA person goes in there, and it actually opens up the Pickles document, HTML document that gets generated, and they can see the health of the system right away. And actually, what another unintended advantage of these scenarios are is that it makes the testing process a lot more efficient. Because if you're a tester, you first test with the scenarios list, but now you can focus more on what's important, which is the edge cases. So what happens if I enter 50 million characters in this field, 10 characters in this field, instead of being solely focused on how the system should work. Yes?
So you were saying that you like this approach because it gives you your documentation, basically.
Yes.
Do you take that documentation, do you give that documentation as it is, or is it maybe something make it a little more readable, or?
I guess the premise here is that can we export this documentation to something fairly readable? And this might not seem readable, but actually we got everyone on board to write their acceptance criteria like this because it's now in a format that makes sense to them. It's kind of like a procedure. Given these preconditions, what a certain action occurs, then there's going to be verifiable results.
So does the actual client read it in this format?
So does the actual client read in the format, like the end user?
Yeah.
No. The product owner, the champion of the project, the person that's the major stakeholder in that, we sit down in the grooming sessions with them and hash these out. Yes?
Pretty earlier question. The other advantage of this, you'll have a history of these tests, and inevitably, sometime down the road, you'll go back to this project and have to add something. And of course, while you're doing that, you'll break something. You'll immediately see in a very concise form what failed.
So he mentioned here going back and updating code that was already out there. So if a project was written like this, you kind of have a little more better starting point because you know which scenarios to look for. And then you can go back in, it's easier to know. And I think one of the biggest, I don't know, jokes, but let's do an impact analysis on this system. All right, if I change this procedure to do this, am I really going to know the full impact of the entire system realistically? No, I mean, it's really difficult to do unless there's like a test suite on there to prove your behavior. So one of the problems with this approach actually is that it's hard to see history. So what was the scenario before? Now granted you could go into your source control system and see what the history of the feature file was, but unless you do that, you don't know what the behavior was before. And that sometimes is actually important when the analyst goes in and sees, okay, how did this work before? And another important thing that this doesn't capture is why. Why are we doing this? Why do we have to have the one be enabled to forward some message to us? Well, it's because it's a convenience for the user, but that wasn't in there. That wasn't in the requirements.
What some organizations do is actually spit out at a release there. What I've seen some organizations do is actually spit out at a release all of the spec, the actual specs, so that they have a historical version without having to jump back. So that you get sort of that history that way, but it's not necessarily clean. Otherwise, you go to source control.
Yeah. Let's give our end users TFS. Any concerns? Let's go back here. Scott. Of course. Yes.
So, any thoughts on how to add this into an existing project where you're not starting from scratch? Should this be to kind of go back and apply this to everything, or start where you're at and go from there?
Okay. All right. So going back and adding this in. So actually, we've experienced this ourselves, and we found that with given the things we were going to do, it wasn't worth the time that it was going to take, because if a project wasn't originally written like this, it is hard to get it up to speed, because you'll start isolating code that you have to put under test, and you start ending up with a mountain of things you have to isolate and put under test. And not only have to put under test with the new behavior, you actually have to prove that the old behavior was working as well. So I guess the short answer is that we usually never did that as an undertaking. You know, we with the legacy code, we kind of did the traditional approach. And we just coded in, did some manual tests, and tried to see if it worked. Now, if there was an opportunity, a good opportunity to put tests in there, we would. But those are kind of rare because it's usually a mess in there, and the risk and the time it would take. Usually these fixes that come in need to happen pretty fast, and that kind of sucks because we want to produce a good product, but if you're under a time constraint, it's difficult to do that. Yes.
Have you been bitten in the butt by taking this approach at any time, or you've taken down this approach or gone down this path and it's gotten complicated, or some scenario comes out where it creates a problem and it's supposed to be solved?
In our experience, not really actually. Where we've gotten more creative is that even though we have this given when then format, we still write some of the acceptance criteria in that, but we don't lay it out in the requirements document or on the acceptance criteria on the user story. It's maybe in a table format because it's easier to do that way, because it's hard to write given when thens for some of these particular scenarios. Now, where this is a huge disadvantage is UI. Think of all the things you have to do for UI with this. Think of how many behaviors you have to go through in order to prove that the UI works. And that's tough. And this works really well with compiled code, but JavaScript. Now JavaScript has, I believe it's a JSpec, or something similar to JSpec where you can do, or is it Jasmine? I think Jasmine is the suite that you can use to write acceptance criteria like this, but it's a little clunky and it doesn't work as well as kind of compiled code. Tell you what, when we first approached this, I was scared because it took a lot of time to get up to speed. But now that we've done it this way, I mean, we've kind of turned our organization around. We are all starting to do test-driven development because it has produced a lot leaner code and in our code base, and it was a lot easier to maintain. Anyone else? All right, so let's wrap it up here. So let's take this Japanese concept of Kaizen. Let's try to identify problems in our process and try to continuously improve it. You know, we need to get over the fear of failure. Like I said, I was truly scared when I first went this way because it wasn't a traditional approach. But after trying it, you know what? It actually worked out pretty well. You know, mistakes are going to happen, and we need to learn from the past. And as software professionals, we need to actually put out a good product. And I actually stole this quote from Uncle Bob Martin, but we should really focus on not shipping shit. Let's not put something out there that we know maybe not be of the best quality. So let's get over the fear of failure. Let's, you know, give these things a shot. Because ultimately, thank you very much, everyone. If you'd like to contact me, call me on Twitter. My handle is Richard_U. You can email me with any questions you may have, or if you want some advice. Thank you very much for coming out tonight. Thank you to Direct Supply for providing the venue. Thank you.
All right. Thank you, Richard, for coming. A little more entertainment value than most of our presentations.
I can email you the Katy here.
He's giving dance lessons, so thank you afterwards for that. Quick run through our announcements as you're filling out your evaluation forms. Go ahead and fill those out. We have only a small basket to collect them in, so please fold them in half and pass them towards the center. And Jason will collect those in a few minutes. We've got a couple things to give away. While that's going on, quick recap of the announcements from earlier. First of all, thanks again to Direct Supply for hosting us as always. If you're interested in going to a Windows 8 development camp, one day, build an app today. Seminar is on January 25th. Get our newsletter, there's a link in there. Sign up for that. Don't get our newsletter, come see me afterwards, and I'll make sure to get that information somehow. Next month in February, our meeting is